The diagram shows a sector of a circle with center O and radius 5 centimeters. The length of the arc AB is 7 centimeters and angle AOB is in radians. Explain why theta must be greater than 1 radian. We know this is 7 centimeters. Now, without writing it all down, the definition of the radian is that when we have a sector like this, if that's 1 radian, in fact, I'm going to write it all down, but with the diagram, that means that the arc length is equal to the radius, and here 7 is greater than 5. So I think that pretty much does it. Okay, so now we actually want to find the value of theta. So we can use L equals R theta. And we've got 7 equals 5 theta. And that means that theta will be 7/5, or if you like, 1.4. Calculate the area of sector AOB. So that's the whole sector. Well, we know that the area is a half r squared theta when theta is in radians. So that's going to be a half times 5 squared times 7/5. And of course we've got a calculator, but I can do this without. So that's just going to be 35 divided by 2, which is 17.5 square centimeters. And finally, for this question, we want to calculate the area of this segment here. So what we're going to do is the sector and then take away the triangle. So the area we want is the area of the sector, which we already have. Take away the area of the triangle. So that's going to be 17.5. Take away, now here we're going to use a half AB sine C. And the AB is the 5 and the 5, and the angle is the C. So that's a half times 5 times 5, so 25, times the sine of 1.4. And all we need to do is make sure our calculator is in radian mode. So it's in radian mode now, and then I can do 17.5, take away 0.5 times 25 times the sine of 1.4, and that gives me 5.18 square centimeters, giving the answer to 2 decimal places.